Alright, in this video we're going to go over our first example of hashing. So we're going to do this with one example and go through the whole thing, but first just review what hashing is. So in order to create a hash table, you need to know something about the data, and by knowing something about the data you can create a hash function that will basically map the key that you're searching with to an integer index. Then you need an array, which we call the hash table, and it needs to be big enough so that every hashed item has a place to go, and the hash table will store all of the data that we're searching for. So the example we're going to use is looking at part numbers from a company called Annabrew. And let's assume that the Annabrew company has car parts, and the part numbers for the car parts are following this pattern. So they start with a capital letter and then they're followed by 4 digits that are separated with a dash in between. So an example would be A12-98 or M73-01. So in general, we have a part number that's of the form capital X, where X is a capital letter, and lowercase y, y-yy, which is any combination of digits. So the question is, well, what we're trying to do here is create a hash table that can take in a part number and then find the data associated with that part number, so storing whatever it is that you need to store with the part number. So in order to do that, we need to create a hash function, and we'll create a hash function based off of the form of the part number. But we also need to create an array that we'll use as our hash table. So the question is, how large does the array need to be in order to be able to have one spot for each of the possible part numbers? So to do this, we need to kind of think about how many different combinations we have with any particular pattern. So in this case, we know that the first letter, the first letter of the part number is going to be a capital letter A through Z. So there's 26 different combinations for that first letter. We can ignore the dash because all part numbers will have the dash, and so from there we know that we have basically a 4-digit number. And with a 4-digit number, we can work through and convince ourselves that if we get all combinations, we're can start with having all zeros, and then we can have a 1 here, and we can go all the way up to 9999, and this will come out to 10,000 different possible combinations of numbers. So what that means is that the first letter in the string could be 26 different things, and then all the different combinations of the last 4 amount to 10,000. So if we multiply those together, we will get 260,000 different combinations of part numbers. And so the reason that you have to multiply these together is because you can have, A000, A0001, A999, or you can have B, right? So multiplying 26 by 10,000 gets basically all those combinations. So our array is going to need to have 260,000 elements in order to be able to hold all possible part numbers. So now let's talk a little bit about what this type of code looks like, creating a hash table with this type of data. So first we're going to have a struct. The struct is going to be called part data, and you can just imagine that the struct is what stores all of the data for each individual part number. And then inside of main, we will set up an array. So first we need to save the size that we figured out, 260,000, and then we just need to allocate a C array. The C array is going to be of the type part data, because you need to have enough memory in each element to hold the whole struct. And so now we have a C array that holds n part data structs. Then all we're going to do is start storing stuff in the table. So in order to do that, you're going to take a part number and you hash it. And remember, hashing it is like doing some calculation on it that sends in the key and gets out an index. So what's returned from the hash function is the index that matches that part number. And then, the table can just be filled with its various components of the struct, the name, the price, whatever. But the important thing here is that you hash the part number and get out an index, and then you use that to index into the table that we created. So that's how you put stuff into the table, right? You hash, you get an index, and you fill it. What about looking up in the table? Well, let's say that we were given some part number. We'll save it to the string partnum, and we are just going to again call our hash function, which will convert that part number string into an index, and then we'll just use that index to directly extract whatever we want from the table. And so what's important to remember is that this operation here is constant. Every single time it's going to take the same amount of calculations to convert the string or whatever the key is into an index. So now you're probably wondering, well, what is this hash function? So what does it do? How is it able to convert a string into an index? Well, it turns out it's actually really nothing fancy. So you want to view the array as 26 bins. So let's say this is our array. So the first part of the array will hold all the part numbers that start with A, and then the second bin will hold all the part numbers that start with B, and each one of these is going to have 10,000 elements in it. And so it'll get you all combinations, right? So you'll have like A0000, A0001, and then somewhere at the bottom you'll have the 10,000th element, which will be A999. And then B will be the same. It'll be B0000. I'll just write it so you get the pattern. B001. And then B9999. And then down at the bottom you'll have Z's, which will be Z000, Z001, and then Z9999. So how do you do that, right? So that's the structure. You have these bins that the array has, and each bin is going to hold one of the letters. So now it's just about writing the code that's able to translate the string into these bins that associate with these indexes. So the first thing you need to do is you need to determine which bin it's in. So what you'll notice is, so each of these bins has 10,000 elements, right? And we can call this bin 0 and this bin 1. And then this bin would be 25. And so how do we get the A's to convert to 0, the B's to convert to 1? Well, first we're just going to extract out the character at the first position of our part number string, and we're going to subtract off a capital A. And so capital A minus capital A is 0, capital B minus capital A is 1, and etc. So that will convert these A's, B's, C's, all the way up to Z's into numbers. And I'll show you how we'll use those numbers in just a second. Then all we're going to do is we're just going to go ahead and delete the letter off of the part number. We don't need that anymore. We extracted it. It's now called bin. And then we're also going to erase the dash. And in general, we're going to erase anything that's common in every single key that's passed in. And so now we're left with just a 4-digit number. So it's still a string, right? So we'll first get it into an integer by using STOI, and then it's just a calculation. So these first indexes are 0 through 9,999. So if we take the bin, which is 0 for A, and multiply it by 10,000, we will get 0 through 9,999. Then for B, bin is 1, and so the elements are going to, the elements here are going to be 0, 0, 0 to 99. And then for B, the elements are going to be 1, 0, 0, 0, 0 through 1, 9, 9, 9, 9. And so that's what this calculation here is doing, is it is taking that bin integer that we calculated from our character, multiplying it by 10,000, and that's going to move it to the different bins in the array. And then the offset is just going to be, what comes out of the actual YY part number. So this is an example of how writing a hash function works. It's like there's nothing fancy about it, right? It's just a bunch of like parsing strings and doing a bunch of arithmetic so that you can get all the combinations in such a way that every part number has a unique element index to go to. So I hope this gives you, oh, I have one more thing. So let's say that, okay, so we know that we have now created a hash table that has 260,000 spots, and we also have a hash function that uniquely translates all part number strings into an index. But let's say that the Anna Brew company sells 4,800 parts. That's how many actual parts they have. They don't have a part for every possible combination. So the question is, how much space are we wasting in the hash table? So it's actually quite a lot of space if there's only that many part numbers, which that is a reasonable amount of part numbers that could be possible, right? So we're wasting 98% of the hash table in this case because we have this huge hash table that allows for any possible combination of part number, characters and digits, but actually those part numbers don't even exist. So that's something to consider with the hash table. So if you remember in the last video, I said what are the pros and cons of using hash table versus a tree? Well, a hash table is really fast, right? We just have to do this quick calculation. This is the calculation that I kept referring to. We're going to extract a character, erase a couple things, convert, and return. And it's the same regardless of how many pieces of data there are, right? So it only depends on the size of the part number, which is fixed, right? Because we're designing the hash function for a particular part number form. So it's constant. We can constantly access our data. However, it is has excessive memory use, right? And not using 98% of the memory that you're allocating is not very efficient. And so you can obviously tone this down quite a bit, and you can work on developing a better hash function for just the actual part numbers that exist. Lots of different ways to go about it, but that kind of can give you more tangible evidence of those two pros and cons that we talked about. So that's it. This is just our first kind of look at hash tables with a example of this part number. So you're kind of seeing the whole process of what that actually means to write a hash function that's able to take the key and translate it to an index, and then how that index is used to directly access into the table, whether that is for insert or for search. So that's it for this video.